Hey guys, I thought I'd end the weekend with this one really interesting video I'm going to show you. It's real quick, but it proves a major point about the reason why these guys use the 11 by 14 system. And it also shows you something kind of interesting that many of you may not know, but that these two different versions of pi that you see here, the 3.14181818, which we see a lot in these ancient places. And then also we have the 3.142857. So it turns out, if you remember, that I was telling you that depending on what type of a circle it was, I would divide by a different ratio. So it turns out that if we use pi, there's two different variations that we use, something kind of magical happens. And then also it's going to kind of prove the point I was telling you about pi that we use currently and why it just doesn't make any sense for this system. So the first thing I'm going to do before I show you the magic is I'm going to plug in our standard version of pi. Now, I told you I'm a very visual person. I don't know why I haven't seen anybody put this type of thing together before. But seeing it visually really makes a difference. So right here, these values are trying to calculate the circumference for these values. So this cell right here is trying to calculate the circumference for these 11 circles. So what these are right here are circles of sizes multiplied by 11. Now there's probably a lot more numbers that divide by 11, but I decided to go ahead and just put all the 11s, so we have 11, 22, 33, and so forth and so forth. And so these are all the 14, so these are incremented by 14. So what you'll notice is that, of course, if you take any of the numbers that are on the 11 side, right, like say 55 divided by 70, you basically get pi over 4, right? So we multiply that times 4. You get pi, 3.142857, and so on, right? And so this is what comes out when you use the two different circles together. When you're looking at one size circle, though, and the other size, it depends a lot on the value you get. Let's take a look at something. If we just use regular pi, okay, so this cell that I'm showing you right here controls pi for all of these values in this column, okay? So if I use pi as we get it from Microsoft Excel, then this is calculating the circumference for this circle here. And let's do that for the 14s as well. So this is equal to pi. And so you can see that what we've got is these numbers may be exact or pretty close to being exact, but the difference between this and what we see with the other ones is within a margin of error of usually like 1,000th or 10,000th of a percent. But the advantage of using it this other way instead of using this particular one is that you begin to see the harmony in number, which is what these guys were doing and the reason why they used this particular system. So the next thing I'm going to do is to kind of show you the way this works is I'm going to take the 14 circle pi and I'm going to plug it into the 11 circles and we get this. We're starting to see a little bit of a pattern there, right? But we're still lacking. And then I'm going to take the one that is the 11 and I'm going to plug it in here. And it looks like this. So we can see that there's some kind of a pattern there, right? But now let's switch the values. Let's use the 3.141818 and we'll put that in the 11 circle column. And we'll take the other one and we'll put it in the 14 circle column. Now look what happens. And I had to scratch my head a couple times when I looked at this because I was like, am I showing all the decimal places? So if we do it this way on the 14, there are no decimal places. They are all integers all the way down when we use this. Here's our 594 by 756, and this is indeed the circumference minus a very small fraction. 756 circumference is basically 2375.999. It's very close to 2376. But what we can see is the harmony in number, because as I said, 2376, if you divide that by 2, it's 1188, which is twice the value of 594. And we can see the 186624 come out, and take a look at these numbers that we see here. 10368, 20736, 31104. These are all precession numbers. You see this? All precession numbers. Now, the 707 one is not in here, which I think is interesting, because, I haven't put, number one, I haven't put all of the things that divide out by 11. Obviously, 707 divides by 11, it comes out to 101. But just for the sake of showing you the way that this works, because all of these, you get pi over 4 if you divide this by this, right? They're just multiples of 11 and multiples of 14. But the magic is when you look at the circumference and you use the correct version of pi for depending on the type of circle. So if you have a circle that is whatever the number is, take a look at its factors. Remove the decimal place, and then take a look at the factors of that particular number without the decimal in there. Usually about 5 digits is sufficient. In other words, if there's 3 numbers after the decimal place, then just usually use those 3 numbers, unless the numbers are extremely large. Then you may not find something out there that'll give you those factors. But anyways, these are precession numbers. As you can see, the 5184 is right here as 518.4. I mean, this is just amazing. So anyways, I thought I would share this with you because I think this is a big deal. It proves a couple of things. Number one, you cannot use pi the way that it is when you're dealing with this system. Okay. Number two, pi varies depending on what you're doing here, right? If you're using an 11 circle versus a 14 circle, and it shows us that these factors are important in determining the geometry of these things. So that's the reason why the factors are important in this whole 186624 thing, because all of the factors within inside it are the ones that keep popping up, and these numbers have to do with the precession that I keep talking about. So anyways, this is definitely one to share with your friends. If I can stay away from this computer, I'm going to try to take a break for a while. But you guys have a great weekend, and I'll talk to you soon.